And so again, a lot of people ask questions about, there's so many different pathogens out there. What does it mean to get infected with one pathogen and another? Is it going to make you more susceptible, less susceptible? Can pathogens preempt each other? Can they offer protection? So the general question is, what is the impact of prior infections on the susceptibility to a novel pathogen?
So I'll start that, and I hate to start. I hate to start by saying, well, it depends, but it does depend, and I think it's biology, and so it's going to be variable. And we can have good examples where a prior infection can give you protection, and why would that be? All right, well, it could occur because the two organisms that you've been infected with share some features that your immune system can recognize. And so in a sense, it's just like the first infection vaccinated you, and it gives you protection against the second. And the other circumstance could be that the first infection makes you much, much more susceptible to the second infection. And there's a whole lot of reasons why that could happen. And I may boot that over to a few other people, because some of these can be because your immune response is actually what's making you sick. Okay, so the immune response may simply be inappropriate, and when you mount it again, it's typically more robust on the second exposure, and so you get sicker as a consequence. So we could probably take the whole AUA for the whole semester talking about all of the different cases where this can occur. It's really one of the things that makes infectious disease research so challenging and so interesting, is because many of these things can be quite difficult to predict.
I think it's a really good question.
Yeah, it's a great question.
And it's a really good question because we often think about either one infection or another infection, and yet we should be thinking about the community of infections and the integral of all past infections in every human, in every individual. Now
that's complex.
Yeah. That is, but one of the things so if I take an ecological view of it, I think of it in two ways. One of those is the direct interaction. So if the pathogens are in the same tissues, for example, then they can make you more susceptible to infection. So classic cases of venereal diseases and HIV. If you have a venereal disease, you're more susceptible to an infection from HIV. But there can also be interactions that, as an ecologist, I think of being immune-mediated, as you talked about, Mary. So, for example, if you have gut helminths, you're more likely to be shedding HIV at a higher rate. So there's an interaction that's probably mediated through the immune system. And one of the simple solutions is to give somebody an antiemetic for a few cents, and they will reduce the rate at which they're shedding virus.
And so I just want to also highlight that most of us work on animal systems, and that is excluding a large selection of the living world. And next week we're going to have Marilyn Rusink, who's going to come in, and she works on plant viruses. And there are lots of cases in plant diseases where there is a non-specific defensive response to infection, in which being infected with one parasite or pathogen increases those defensive responses, and actually then can block out infection with other parasites. So actually, getting infected with one thing can be protective against another. And if that first thing is less severe or less lethal, then it can actually be beneficial to get to get the lesser of the two evils. And some of the work that I did in my PhD at Penn State focused on that interaction, where we were looking at squash plants that were getting infected with a bacterial disease, and as a consequence were less likely to be infected by a viral disease that was worse off for them.
So they have actually used diseases to control other diseases.
I was about to say, so one of the interesting approaches to controlling mosquito-borne diseases is to give the mosquitoes other infections that will make them more robust or better able to deal with infections of the diseases that we care about. So for example, block malaria transmission in mosquitoes by giving those mosquitoes bacteria that have a property of enhancing the immune response, the generalized immune response. So these interactions can go both ways, and they offer us, potential gains, public health gains, as well as complexities.
I think one of the most strange ones was the way they used, one solution for syphilis was to give somebody malaria.
Yes.
because it gave you a huge fever response, and so that killed the syphilis, and you were just left with malaria.
Or you were dead. So the whole thing worked by trying to cook out the syphilis, and it mattered as to whether you survived the malaria but cooked out the syphilis. And so the outcomes were you died from the malaria, died from the syphilis, or it worked, and it worked in 20-30% of cases.